So everything that you work in Grasshopper is going to happen here, right, on your canvas, on this gridded area right here. So you can double click on the canvas and search for any component, or a component is essentially anything anything that drops into your canvas, right? Whether it be something that modifies something else, something that creates geometry, or something that just controls data, right? So the first thing, well, what we're going to do in here is create an optimized tower, right? You guys are doing environmental design, and that's the reason why we're using Ladybug. So I'm going to start with showing you the interface on how I would create a tower, a spiraling tower in Grasshopper. So first things first, right? What do I need to create a tower? Well, the simplest thing I need, right? If I break down a tower to the very simplest sort of interpretation of it, is I need a base point, right? I need a point from which this entire thing is going to grow, right? So when I'm looking through my tabs up here, right, I'm going to think, okay, I need to establish a point. Now, we have our parameters tab, right? And in here, we kind of control all this geometry. So all these are used to collect. It says contains a collection of circles, right? So you can establish circular geometry to this parameter, right? Or you can select, or you can set numbers, colors, and matrices to everything under this tab, right? You also have your input over here, so you can input number sliders, right? So you can slide through values that control your script, as well as a bunch of other mathematical and visual parameters that you can input. So you have your math, which modifies any of the values that you're working with in Grasshopper. Your sets, right? If you're working with a network of curves, right, or a list of values, sets helps you manipulate those lists of data, whether they be objects or numbers and values. So when we get to the vector tab, right, vector, under vector we have three things actually. We have vectors, points, and planes, right? So the difference in those things is that a plane has a point, right? It has an origin from where the plane starts, but a plane is more of a mathematical concept than a geometrical one, right? Because if you're talking about the XY plane, right, you're talking about a horizontal plane. A plane can, right here I already have, then there's the other tabs, but we'll get to those as we develop this tower. So we already have the first thing that we need to create a tower, which is on our origin point, right, a base point. So I can go under point, and hovering over any one of these is going to tell me what it creates and what it needs, right? So if I look at all of these, right, these down here look pretty complex and they look more analytical. These look like they're relating points to other things, such as planes or surfaces. So in this first section up here, I can see that there's the most basic, right, point components. And if I hover over construct point, I can see construct a point from XYZ coordinates. So here I understand I'm going to end up with a point, and all it's going to ask for is coordinates, right? So I select that one. It's going to be attached to my mouse, and I click anywhere on the canvas to place that. So now we have our first component, right? If you go to display, you can either display the components with icons, which I personally don't like because, well, especially in explaining something, you can't do much with this if you haven't seen it before. So I like to keep full names, because if you see this, you can double click on your canvas and you can search construct point, and there it is. And you can hit enter and it'll drop into your canvas. So on the left side, I have my inputs, right? So these are the things that are going to inform what comes out the other side, right? And what comes out the other side is a point, right? And when I hover over it, it gives me a parameter symbol of what that is, right? If we remember our parameters tab, right? Here we have point. And so here we understand that there's a point coming out of here. There's a further description that says it's a point coordinate. And then even below that, it says there's only one value coming out of this. So there's only one point. And you'll notice that it's 0.0, comma 0.0, comma 0.0, right? X, Y, Z. So as I see this point on the origin of the model, right, and I see that that point is located at 0, 0, 0, right, there's a correlation between the information, the numerical data of that point, and its location in Rhino. Yes? So if I want to change that location, right, let's say I want to move along the x-axis, which is always the red line, right? So I hover over x-coordinate, and I see, okay, x-coordinate, one locally defined value, 0.0, right? And I see that parameter symbol again, right? 0.1, that white text in the black symbol. So if I go to my parameters, right, and I know that numbers are here under primitive, and I can look for 0.1, and 0.1 is just a number, right? So let's say I wanted to use this component right here to introduce a number, right? How these components work, the parameter components, I could have a bunch of numbers here on the left, and I could collect them all here in this component, right? But all these components from the parameters tab, you can configure by right-clicking on them. So if I right-click on them, I get a series of options, right? Most components have these options right here for wired display and data configuration, but I'll get into that a little bit later. Here you have, right, here's where we set the information. So we can set multiple numbers here, or we can just set one number, right? So I'm going to set 1.5. And then I'm going to click on this node right here from the output and plug that into the input of the construct point. So now we see that I'm working in feet, and I plugged in 1.5 here, right? So if I zoom in, I see that that point has moved 1.5, right, in the x direction. Another way of doing that is using a number slider, right? So that's over here in your parameter inputs. So if I pick a number slider, and I drop down here, it's going to default to be between 0 and 1 with 3 decimal places. Right? If I plug that into the y coordinate, right, it's now moved from that location that we had it on the x-axis, it's moved in the y direction 1 unit. Right? Now this is what I was talking about. If you move a point in Rhino, the point's now there. If I want to move back and move it again, I have to undo. In this case, instead of moving 0.1, I want to move 0.5. I can slide to 0.5, and the point's moving as I change those values. Right? I can also double-click on the number and type in whatever number, right? So that's if I drop in the default number slider. To edit number sliders, you double-click on the title, number slider, right? And here I can change the name of it, so I can change it to Y position, right? We have here, this means floating point. So when you have a floating point number, that means you have decimal places, right? So here is where we have 3 decimal places defined for this number slider, right? And then we have integer numbers, right? If I go here, there's no longer any decimal places. But my minimum and maximum for this number slider is still 0 or 1, right? So what that means is right now this number slider, since it's in integers, there's no decimal places. The minimum is 0 and the maximum is 1. I can only move this number slider from 0 to 1, right? Whereas if I change the maximum by double-clicking here to 10, I can now slide from 0 to 10 through the integers, right? No decimal places. I can also just type any number into the canvas when I'm searching for a component. So let's say I type 11.25, right? So this number slider is now going to 100. And the reason for that is if I type anything between 0 and 1, it's going to create a number slider with those decimal places that I typed in between 0 and 1. If I type in a number between 0 and 10, even 10, it's going to create a number slider between 0 and 10. I didn't put any decimal places, so there are no decimal places in this number slider. So because I typed in a number larger than 10 here with 2 decimal places, right? I typed in 11.25. I'm getting a number slider from 0 to 100, right, with 2 decimal places. So whatever number you type in, it's going to define a range, and it's going to define a quality to it, right? How many decimal places, or if it's just floating through integers. So with this number slider, I can now control the Z, right? And I can move this point up and down. So the combination of these things, right, starts to give values to manipulating this component in Grasshopper, this geometry. I can also use the same number slider for 2 inputs, right? If I just click this node and I connect it to Y, I replace the one that was there. And now, as I move in the Y direction, I'm simultaneously moving in the Z direction. Right, let's better see that. right? It's moving further away as it moves up. It's moving diagonally, right? So I'm going to keep this base down there. And now I'm going to create a tower, right? So first thing for creating a tower is if I want to say, let's say I want every floor plan to be the same shape, but I want it to rotate, right? I want it to be like a spiraling tower. So from this construct point, I'm going to define a very simple shape. So I'm going to say that I want to outline this floor plan with a curve. So remember we stopped at the vector tab, now we'll go to the curve tab. So under the curve tab, I have a bunch of things, right? So whenever you have anything in Grasshopper, right, you can either construct it, like we did with these points, with this point. We plugged in values to create this point, right? But there's also things that we can take away from this point, right? I did a construct point. If we did a deconstruct point, it would be the opposite. The input would be a point, and the output would be its coordinates. So under curve, we can see the same type of thing. We have primitive, right, to create very simple curves. And we have analysis, right, to extract things from curves. So for example, point on curve, right, would give me a location on a curve defined as a point. So if I want to find a middle point, if I want to find 1/3 of the way on that curve, or 2/3 of the way on that curve, or 3/4, I would use point on curve, right? In this case, I'm trying to create something that would be optimal for a floor plan. So a closed polycurve, right? Like a closed curve that's multiple segments that are all defined around a center point, right? So I would go to primitive, and I'd start to look for that component that meets that criteria, right? So fit a line into a collection of points. No, I only have one point. I don't have a collection of points. A line, create a line between 2 points. I also don't have 2 points, right? I only have one. So is there something I can do with just 1 point? So for example, we see this one, right? That symbol looks pretty promising. We see 1 point in the center of a circle. Create a circle defined by a center, a normal, and a radius, right? So that could be something if I'm trying to create a circular tower, but if I'm trying to rotate the floor plan, rotating a circle isn't going to do anything. So that's not really what I'm looking for. However, we go down and we see something similar to a circle, a polygon, right? Create a polygon with optional round edges. So that's interesting. So that could be one, right? And now when you're doing this search process, notice that there may be other components that help, right? Polygon directly meets my criteria right now, but rectangle 2-point, right? Create a rectangle from the base plane and 2 points, right? So maybe if I want to introduce another point to this script, I could use this one, right? And it might be something that I want to pursue. But what I'm trying to get across here is if you see more than one possible component for you to proceed, throw them all into your canvas, right? Throw them all in here and then see what their inputs are. See which one best fits the data you already have, or see if you can create any additional inputs to make other components work, right? So in this case, I don't really want to bother with creating another point to make a rectangle. This one is only asking for 1 point. And remember I said a plane is always defined by a point, right? A point, and then from that point it keeps on going forever. So I can understand that for plane I can use a point, right? Then it asks for a radius, which in this case I hover over and I see it's just a number. Segments, which is also a number. In this case, the 7 indicates an integer, so no decimals. And a radius, right? A filleting radius. So fillet is just rounding out the corners, right? So I'm going to go ahead and use the polygon. Now, this percentage that you see down here, right? If you go back to display, canvas widgets, you probably have all of these enabled except for the profiler, right? What the profiler does, it just tells you which component in your script is taking up the most amount of resources on your computer, right? So construct point in this case has already been calculated. It doesn't need to be recalculated, right? However, polygon right now is taking up all the computing power, right? Because it's new. It's the latest thing that was put into the script, right? It's still being processed. So let's start putting things in here, right? So I'm going to put in the point to the plane. And you'll see that it lays flat, right? The hexagon lays flat. What if I put the point, as I mentioned before, through a YZ plane, right? You see that YZ is a vertical plane. If I put that point as the origin for that plane, and then I plug that plane in to the polygon, the polygon is now existing on the YZ plane, right? If I don't define that, it's going to default to the XY plane. Since I'm doing a tower, in this case, that's what I want, right? So then I define a radius, and I see that the radius right now is set to 3.0. So yeah, I'll work between 0 and 10, and I'll work with 1 decimal point. So I'll type in 5.1. And now I have a properly scaled number slider. Although if we're working in feet, let's just say if we're working for real, what's good for like, I'm just going to go with 60 feet. So the radius would be 30. Right? So that would make one floor. That's 30 feet in radius, so 60 feet across. Right? Segments, right? 6. So I can create any amount of segments here. So if I want to work with an octagon, but I want to switch to a triangle, I want to switch to a square, a hexagon, whatever. I'm going to use a pentagon. Fillet radius, it's set to 0.0, right? And it's a radius, right? So when we're talking about curving things and it's asking for a radius, right? Everybody knows CAD, right? When you fillet a corner in CAD, what happens if you plug in a radius of 5? It almost, well, it depends on the scale you're working at, but when you put in a number that's too large, it almost creates a circle in that corner, right? Whereas you need to bring that number down to just create a curve. So I understand that here, if it's set to 0.0 and 0.0 means a straight edge, I understand that this number doesn't have to be very big. So maybe I can stay between 0 and 1.0. So I'll type in 0.55, plug that into my fillet, and I can see that curve being really, really subtle. And as I increase that number, right, it'll increase that curve. So if I were to do, like I was saying, if I put in a number that's too large, like say 15 for that radius, I'm pretty much making this closer and closer, looking like a circle, right? And this is what I mean, that you can go back and forth and look for the optimal results. So actually, since I see that 25, about 25 is a true circle, right? I'm going to actually keep this number slider, add 2 decimal places to it, and bring the maximum down to 25. Right? Now this number slider is optimized to take me from straight corners all the way to a full circle. And that's the only thing that I can go from in between. Is everybody following me along okay now, so far? Okay. Editing this number slider? So you double click on the title, right? And then I make sure that my floating point quality right here with the R is selected. And that way I can define how many decimal places. Right? So I'm going to define 2 decimal places. Here's my minimum and maximum values. So I'm going to set the maximum to 25 because through testing I realized that 25 made a full circle. So that's my maximum right now. And then here I can even change what value I want to use right now. But I can change that after the change the number slider too. Here I can change the title of it. So I can say fillet value. Right? And I'll hit OK. All right, so now I need to recreate this shape, right, vertically and stack them up so I can create my tower, right? So to do that, I would move this circle upward, right? Or not this circle, but this shape. So I type in move, and I get a move component, right? Sometimes it's that simple. Before you even start looking at the toolbar, just say like, oh, I need to, I don't know. I need to divide this curve into points, right? So you do a search and you search divide. And then the first thing that pops up is divide curve. And then you realize, oh, I can also divide surfaces into points, right? I can divide a curve by a certain amount of length, right? So whenever you say like, oh, I kind of need something like this to happen, search for it first. And then if you can't find it, then you can start saying, okay, I'm dealing with curves. I'm trying to break down a curve, so I'll analyze it. Or I'm trying to construct a curve, so I'll look at primitive, right? Splines are usually through a network of points, right? You kind of follow through a series of points. So that's how you can kind of you just have to dig in and familiarize yourself with what tools are available to you, right? So with the move component, I'm going to plug in the polygon into the geometry that I want to move, right? Now it already moved, right? It moved up and it moved a certain amount. So if I hover over motion, I see the symbol for a vector, right? The arrow in the black symbol, and it's defined as motion, and it's a translation vector. So it's understanding a vector as a direction for motion. And then we see, remember before, we had that point defined by x, y, z. Here we see that again, x, y, z. But here we have 0.0, 0.0, and then we have 10, right? In the place where the z value goes. So I understand that this move component has defaulted to moving this geometry 10 units in the z direction, right? And hovering over these things, these inputs and outputs, are always going to give you hints as to what's going on. And if you're simultaneously looking at what's happening in Rhino, you can deduce, right, what's kind of going on here.